Hello and welcome to today's webinar, What's New in vSAN? Getting Started with the Hands-On Lab. This event is brought to you in partnership with our friends at VMware. Thank you so much for joining us. If you're wanting to learn more about VMware and specifically VMware vSAN, you're in the right place. This is going to be a really fun event. We've got a ton of demo, and the cool thing about this is that you can follow along with what you see here on this event live in your own web browser. So I want to call your attention right away to the handout tab, and it's there that you'll find a link right at the top to the VMware Hands-On Lab that you can try what you see here for yourself. And while we're there, I should also point out that the VMware Hands-On Lab guide is available as well, and so are resources on VMware vSAN and running mixed workloads on VMware vSAN. So check out those excellent resources and follow along with us here on the event. This is all completely free. That's another cool thing. We're not trying to sell anything here. We're just trying to help you educate and help you get educated on the power of VMware vSAN. My name is David Davis of Actual Tech Media, and I'll be serving as the moderator. Like I said, we want these events here to be educational, and we encourage your questions there in the questions pane. I see many of you have already said hello and good afternoon. Of course, we appreciate that, but we also want your technical questions on vSAN, how it works, what it works with, what are the features, benefits, all those types of things. So we encourage your questions, and we'll be doing a Q&A session with our expert from VMware at the end of the presentation today. We even have a best question prize, which I'll talk about here in just a moment. But first, I should mention that at the end of the webinar, I'll be announcing the winner of our Amazon $300 gift card door prize. If you're watching this on demand, of course, the drawing has already occurred. The prize terms can be found in the handouts tab as well. And then, as I mentioned, we also have the best question prize for a $50 Amazon gift card. Of course, you have to ask a question to be entered into that drawing and meet the Actual Tech Media prize policy. All right, so with that out of the way, it's time to kick off today's VMware vSAN event. I'm excited now to bring in Mr. Zane Alcorn, vSAN and HCI VMware engineer at VMware. Zane, it's great to have you on. I'll hand it off to you. Take it away.
Hands-on demo here in a second, but wanted to kind of set the stage a little bit first. And so VMware's goal is to really give our customers the power of choice. And that really does continue in what we call the hybrid cloud era. And so the evolution of vSphere and vSAN really means that it can now be the platform for management for business critical applications, as well as those cloud native applications. And so data centers that are powered by vSAN can offer scalability, flexibility, and manageability to meet nearly any demand. And that's really the cornerstone for our customers that are looking to build out that multi-cloud solution, powering those existing and next generation applications. And so how organizations really provide those services to support their customers and those business processes is obviously changing very rapidly today. And not only are applications changing, but so are the options and how and where to best provide those services from. Should it be on-prem? Should we utilize the public cloud? Or should we use a little bit of both? And really the industry is demonstrating that the combination of those two really serves most use cases. But once we do that, how do we create a combination of those two using a common set of tools? And this hybrid cloud can really be achieved with VMware. And so we're going to jump into a little bit of how. And so when it comes to hybrid cloud, that really means interoperability, agility, and efficiency. And we believe that there are a few distinct steps in kind of building that journey as we're going towards that true hybrid cloud. And the first step has really been achieved by most. They've already experienced the benefit of virtualizing the majority of their workloads. And the use of public clouds may also be a little bit of that organizational strategy as well. And workloads in those public clouds often become just another silo to manage and typically are not integrated with any of those on-prem management tools or methods. And so these on-prem data centers are often very complex, and the cloud adds to that complexity. And so the next step is really to modernize that infrastructure through hyper-converged architecture with vSAN, and then add the networking components and the advanced management capabilities with NSX and vRealize on top. And that's really where we're going to focus on today. But just know that's only a step in kind of that stairway to the hybrid cloud. once we can achieve hyperconvergence, then really the extending that software-defined data center methodology into the public cloud and out to the edge to adopt that true hybrid cloud architecture. And so this approach really does kind of abstract those operational differences away from where those workloads will be running and provides more of a common control plane to give our administrators the agility in delivering those different services that we have back to the business. So a little bit around hyperconverged or HCI. So HCI architecture can really remove dependencies from those hardware feature sets. So by abstracting those features that were traditionally brought in a three-tier architecture into light, we really abstract those from the underlying hardware and really address and apply the right settings in the right way for each workload running in your data center, focused on this software-defined methodology. So as we see our customers and different organizations are really looking for that interoperability with public clouds, kind of private cloud environments that may be existing as well, being able to apply these settings in a granular way using software is quickly coming into a requirement. And so let's jump a little bit more into the console to take a look at what vSAN looks like from a day-to-day piece. So jumping into our vSphere console, since we are ingrained into the kernel, our vSAN topology is definitely going to be ingrained with how we manage our existing vSphere environment. So let's go ahead and pop into the vSphere console. And this is really where all of our day-to-day operations, all of our changes, configurations, and things like that are really going to be performed for. And so if we look at our environment that we have here, we do have a data center. So let's go ahead and expand that. We do have a single cluster with a couple of extra hosts. And once we expand this cluster out, we can see that we have 3 hosts, a couple of virtual machines running, but this is going to be our pre-configured vSAN environment that we have here. So obviously having our minimum of 3 hosts, making sure we can supply ample fault domains to be able to distribute those data objects and components on the back end. And so we really do require that all VMs that are in this data store are going to be managed with what we call storage policy-based management. And so when we create a vSAN cluster, we're going to obviously have a data store on the back end. And if we take a look at the data stores here, amply named vSAN data store. So as we're creating new clusters, we have our vSAN data stores, we can really start spinning up virtual machines, cloning these machines, and really tweaking with what those storage policies look like. So if we take a look at that, going to our menu down to our policies and profiles, this is really where all of that storage policy framework can be built. So over on the left here, we can see our different versions of that. We can go ahead and say that we're going to our VM storage policies, since it is a vSAN storage base. If we want to take a look at our existing policies, we see that we already have a vSAN default storage policy. So upon creation of a vSAN data store, we already know that we're going to have a storage policy defined as a part of that data store creation. So if we go here and select our default storage policy, we can take a look at the actual rules that are set up in the framework of what is going to define what that policy looks like. So we can see things like our storage type, how many failures to tolerate we want to have, if we're going to be doing any disk striping on the back end, thin versus thick provisioning, things like that. These are all part of that granularity that we get with the vSAN environment, making sure that we can have the flexibility of having a single cluster that can provide a multitude of data services. So if we do have an environment like that, say we want to change what the policy looks like, it's as simple as creating a new storage policy. So up on the top here, we can just click create. And then this is going to walk us through a wizard of what we want it to look like. So if we want to go ahead and call this test vSAN policy, we can go ahead and click next. The next piece that we're going to see here is really that policy structure. And so since this is a data store specific for vSAN policy, that is the box that we're going to enable. It's not going to be pinned to host-based rules or any sort of tag or placement rules that we're going to have on the back end as well. It is simply going to be a vSAN policy. So select our box and move on. And from here is really where we're going to get our framework for these different storage policies that we can configure. So obviously the main piece going to be here is our failures to tolerate, and also how we're actually going to be protecting that data on the back end, or a failure tolerance method. You can see we have a mirroring and erasure coding at a multitude of number of failures. And that's really just going to be if we mirror full data components at the VM or VMDK level, or do more of that distributed parity, kind of like that RAID 5, RAID 6, in a larger host environment. So for this example, let's go ahead and say our RAID 5 erasure coding. We do want to make sure that we are keeping in mind the minimum host counts for these storage policies. Since we do distribute these data objects and data components at the host level, down in the node level, we do want to make sure we have ample fault domains to distribute that. We'll take a look a little bit about that in the future. But one cool tool here, just below when we define our failures to tolerate, we can see a hypothetical for a 100 gig VMDK. How much storage is that actually going to consume? So if we remember, our default storage policy was using a RAID 1 mirror. We can see that for a 100 gig VMDK, we're going to be consuming 200 gigs. And that is going to be because we have our primary copy of our 100 gig VM disk, and then we have our secondary copy since we are using the mirroring capability. So if we see when we move that from mirroring down to erasure coding, more of a distributed parity, that same 100 gig VMDK is now only going to be taking up about 133 gigs as opposed to that 200 gigs. And so there are some capabilities when it comes to our storage policies, how we get everything configured, and what that space savings is going to look like on the back end from a hardware capability. If we want to set some more advanced policy rules, we can come to the top here. And this is really where we get deep into our different storage policies. So things like our disk stripes, how many times are we going to stripe that data component through multiple disks in a disk group? We can do things like set our IOPS limits. So for those mixed workloads that may have some test dev workloads in the same cluster as some sort of production environments, we can make sure that we're setting caps for certain workloads over others to ensure that that prime time production availability meets where it needs to from a workload standpoint. So things like that can be set from our storage policy creation. Once we go next, it's going to show us our compatibility. So we can see after we created a new data store, we don't have anything that's going to be compatible. We can take a look at either compatible or incompatible data stores. So let's take a look at our incompatible. So the first is obviously going to be our iSCSI, since that is not a vSAN data store and we defined a vSAN storage policy, that's not going to be compatible. And we can see here it doesn't match that policy. But now we see, since we created a vSAN storage policy for a vSAN data store, why are we incompatible with our existing data store? So if we want to go over to our incompatibility region, we can see that it doesn't match because we have our fault has occurred, so our storage fault, which means we don't have enough physical resources in that cluster to meet the needs of what that policy defines. So we're just going to go ahead and say not taking a look at what that can provide. So whenever it comes to adding a host, which we'll get into in a little bit, that would put us in compliance to be able to meet the needs of this storage policy. And so we'll go ahead and leave that there. I'm just making sure that we can have a different policy in the future that's going to give us a little bit more of a space savings. But this just gives us a look at what is compatible, what is not. If we want to click next, making sure that everything we entered is going to be correct, click finish, and then we have our new storage policy. So now we can see we have our test vSAN, and we can go ahead and take a look at everything that we set here as well. So outside of defining these different storage policies, how do we actually apply these? So if we want to go back to our hosts and clusters, we do have our vSAN environment here with a couple of hosts. So if we want to go ahead and deploy a virtual machine with our storage policies here, we can go into our core machine level. We can clone this machine. And so let's clone to a new virtual machine here. And so for this, let's just go ahead and call him core B, and then define the resources that we're actually going to have to deploy this virtual machine. And it's very simple. We can see we already have our vSAN cluster. Let's put this workload on our first host. And so the next piece is really going to be where we're going to select the storage from that. And so we can see with our existing cluster, we have our two data stores that are set up. Gives us a little bit of what's provisioned and what our usable capacity is going to be. So we can go ahead and select our vSAN data store. And so this gives us a couple of options. So we have our VM storage policies that we can select. We can select our data store default or a vSAN data store default. If we tried to select our test vSAN, we are going to get an error that says our consumption is not capable and we are incompatible. So we see that our data store doesn't match that. So if we go back to our vSAN default storage policy, which is our standard that we had, we can see once again our compatible and incompatible data stores for the given policy itself. And we can see the same consumption based on what that VMDK size would be for the given virtual machine that we're going to deploy. So we can go ahead and click next. And this is just going to give us a capability of what do we want to do after the virtual machine is deployed. So let's go ahead and just power that on after virtual machine creation. Then we can click next. Once again, just reviewing everything is correct that we wanted to see. And then we can go ahead and click finish. And so as this is deploying that new virtual machine, we see that it's going to create new data components that we'll take a look at and see the distribution of what that is here in a second once we get that lined up. So now that our virtual machine core B is up, we'll wait for this virtual machine to power on, and then we can take a look at where those different objects associated with that virtual machine can live. So going into our environment here, taking a look at the summary, we can really see all of our different capabilities now that we're powered on. And we can see our different objects that we have, so we know which host we're on, which cluster we're a part of. We can even take a look at the VM hardware that we have in here, so configurations for our virtual machine. We can also, if we want to scroll down just a little bit, we can take a look at our storage policies. And so this does give us, now that we are a vSAN capability, the storage policy that we have defined, and then are we compliant or are we not? So in the case of any host failures, anything that may go wrong from a storage policy basis, this just gives us a quick place to check and say, hey, does everything look good, or do we need to do a little bit more to make sure that we are staying active in management of what that virtual machine policy looks like as well. So if we want to go ahead and go into that, we can go ahead and see our virtual machine here. We can go into configure, and we can see the policies from here as well. So a couple of different places that we can actually see that. And so one thing that I did mention is we can define these policies on the VM or the VMDK basis. Here is where we can actually see that we have two different objects that we could apply our storage policies to. There's obviously our VMDK and then our home files, things like that. For those virtual machines that have multiple VMDKs, multiple components that make up that VM, we can set different policies for these. So things like a SQL database that may have multiple VMDKs that provide a little bit different from a needs for data services standpoint. That is going to give us a little bit of a flexibility here. So we can even change, say, the hard disk file that we would want to have. We can edit the storage policy from here, or we could go back to our policy and profiles capability. But just wanted to show that there are some capabilities that allow us to have some pretty extensive management flexibility when it comes to how we are going to be doing the day-to-day operations. And instead of configuring that hardware or configuring ones to meet the needs of what we think it is, let's tell the virtual machine what we need and then go ahead and pull that from the underlying hardware. So now that we have taken a look a little bit at storage policies, let's expand this cluster out a little bit. So let's say host 4 here. Let's go ahead and move and drag and drop him into our new cluster. And so once we move this into the new cluster, they're going to give us a couple of options. So let's go ahead and put all of our resources in that resource pool for our new cluster. And then we'll go ahead and click OK. And so as we're moving that out, we need to go ahead and take this host out of our maintenance mode. So we can go ahead and exit maintenance mode on this guy. And then we're obviously going to see, once this pulls out of maintenance mode, if there are any issues, any configuration deltas, it's going to give us kind of a bit of a hiccup to say, hey, something you might want to check out there. So we do see that we have a bit of a warning flag. So let's go ahead and refresh. And so now we see there's a warning flag for all of our environments as well. So really, how do we take a look at what that looks like? Since we do have a cluster-wide warning, now let's go ahead and check that out. And so we can see that there are some configurations, some VM NICs that are configured maybe a little bit off. So let's go into our host environment. So we can go to the host that we just added, go down to configure. And so since we saw there were kernel adapters that were looking off, since this is the new host, we can see that we have 3 kernel adapters. So we have one configured for our vMotion, our management network, things like that. But we do not have a VM kernel port that's going to be allocated for our vSAN environment. And so we're going to have to add networking to make sure that we can enable that for vSAN. And so we're going to add a kernel adapter. We can go ahead and select that as default. We can move on to next. We can select an existing network. So luckily we do have, if we browse, we can see that we do already have a vSAN virtual distributed switch configured. So we can add that to this previously existing VDS. The next capability that we're going to be configuring is really around what do we want to enable? So what service do we want to have? Since we do not have storage yet, we're going to go ahead and select our vSAN capability. This is really going to give us the ability for these hosts to talk between each other within that cluster and really provide the vSAN backend. So we can click next. And then obviously this is going to say, do we want to obtain our settings automatically or just use some static settings? We'll go ahead and type this in since we don't have a dynamic that is going to be available for the lab environment. But fairly simple here. We're just going to match up whatever environments we want to have, keep everything on the proper subnets. And then we're going to make sure that we also have everything correct, and we do. Make sure we double check and don't fat finger because we will get a few errors if that does happen. But after that, we're ready to complete. Once again, just review, and then we can click finish. So once we're verifying everything out, let's give this an ability to build, refresh, and then we can take a look at what the capabilities are and if that's helped us out when it comes to our red flag that we got from the configuration side. So if we want to go ahead and verify once again, we can check out the VM kernel port that we just had and make sure that everything is correct when it comes to IP addresses, which everything looks good. So once we refresh, this should alleviate our warning that we do have here. So we do see that we have an HA host status, so we can go ahead and reset that one to green. That's just a part of the nested environment itself. And so that's really when it comes to our storage policy management. We can do things like that. But real quick, before we move on to another topic, wanted to make sure we go back to our policies and profiles, because now that we have an additional host in our vSAN cluster, we can go to our storage policies. We can take a look at that test vSAN that we had. And if we want to go to our storage compatibility tab, now we see that we have, as we refresh, the vSAN data store is still there. That's because we have not added any storage to that host itself. So we just added the host into the environment, but we haven't claimed any disks. So how do we do that? Back to our cluster view. So if we look at everything from the cluster view, on the configure tab, on the left side here, we're going to see a little vSAN environment here. So first off, on the services side, this is really just going to show us all of the cluster-wide data services that we have available. And so things like our at-rest and in-transit encryption, our file service, now HCI mesh with the later 7.0 update 1 and beyond releases, giving us the ability to kind of share those capacities between vSAN clusters. This is really going to be where we can take a look at that. And if we go back down to disk management, this is where we're really going to be managing all of those disks that we can see from our existing hosts. So we can see our first 3 hosts in the environment do already have disks that were claimed, and we have nothing from our last host. And so there's an easy way to do this. We can go ahead and claim our unused disks. And the wizard is going to walk us through what that looks like and then what our capacity can be afterwards. And so we can group these different disks by either the disk model and size to see what that looks like. I prefer to look at this at the host level to make sure everything matches. We can see that we have a disk group for our existing first 3 hosts. Go ahead and minimize those. And then we can take a look at our 4th host that will be adding both caching and capacity to. So one thing we do want to make sure that matches up is whenever we're claiming this as a cache, a capacity device, or even a do not claim, that we're selecting the right type. So making sure that our total capacity and the type that we actually have from a physical media is going to be claimed for the correct tier, either the caching tier for that front end write performance, or the capacity tier for more of that write and usable capacity side. So once we got everything claimed and lined up the way we want it to be, let's go ahead and click create. And then vSAN is going to claim these disks. And so that is really kind of the magic. And especially when it comes to expansion and kind of growing these clusters, either from existing footprint, existing chassis, or adding hosts and disks, it really does give us the flexibility to add what we need and have a simple claim to make sure we're taking the environment and growing that out in the way that it needs to actually be grown. So we'll go ahead and let that build out for a little bit. Go ahead and take a look at our recent tasks. Now we can see that we have 30 disks as opposed to the previous 15 that we did. So if we want to scroll down to our fourth host that we just added, we can see that we now have 2 disk groups. So we saw we had 2 cache drives and 6 capacity devices that got broken up into 2 disk groups that are now mounted and ready to be consumed for our storage side. So if we want to go back to our policies and our profiles, we can take a look at our VM storage policy that we created, our test policy, test vSAN. We should be able to be compatible with our vSAN data store now that our fourth host is also actively contributing storage to that cluster, not just the compute. So the next piece I guess we want to walk through is going to be more so around our vSAN file services. And so this is really something that's a little bit newer for vSAN, but they are used to really create the file shares that we can see in the client from the data store. And so those VMs can access that as file storage, pulling from that same hardware pool. So the vSAN file service really is, it's a layer that sits on top of vSAN to provide those different file shares. And so currently we support SMB, NFS versions 3 and 4.1 file shares. And so let's take a look at what that actually looks like when it comes to a configuration. So to enable vSAN file services, first we want to make sure that we have a couple of network requirements that are going to be met and everything is good for this lab environment. Obviously, that was something that our field reps and our engineers would be working with everyone on the call to help make sure we have that configured. But to get that configured, we would go to our cluster level view. We would then click configure. Like we mentioned, scroll down to our vSAN section, we can see our vSAN services there. And then on the right here, we can see file service. And so if we expand this out as everything loads up, we can see that it's already enabled, which is good for us. We already have a share that's going to be configured. So if we notice that the file service nodes are already created, we can kind of see with these different Kubernetes nodes that is going to be providing those file services to the entirety of the cluster. But that is going to be kind of where we check and get that configured. Excuse me. So if we want to go ahead and check the health of that, similar to checking the health of what the vSAN file services or just general vSAN cluster would look like, we can go to our cluster view over to our monitor tab. This is another great place to be taking a look at all of our vSAN capabilities. Same with our configuring. We can see that there is quite a bit of vSAN information that's going to be pulled here directly to monitor. So once we go through our Skyline Health, this is going to be what we call our vSAN kind of health check. And so we can go ahead and run a retest at any time. This is a great tool just for general monitoring of vSAN health. It runs in line with the VMware best practices of vSAN configuration. So it gives us warnings, gives us alerts, things like that, that may be a little bit different, but it's also making sure that we're keeping everything in line with a healthy best practice environment for vSAN. So after we just ran our retest, we can see that there is an issue that we can see here, and it's that our fourth host that we had added is not a part of our vSAN file services. If you see on the left here, our Kubernetes nodes, those are going to be providing the file service nodes for the first 3 hosts in the cluster, but only 3 are contributing to that. So we need to add that fourth node in the vSAN cluster into the file service capabilities. So if we want to see a great tool that we have here too is the remediation. So if we do find something that is a configuration error, something that's a little bit off, we can remediate right from the health check as opposed to going down a different rabbit hole of which capabilities we need to fix to be able to remove whatever alert or warning we've seen. So if we're meeting this file service, do we want to proceed? Yes, we do. Awesome. So really making sure that whenever we create these different file services, specifically for NFS shares, there are some considerations there. Usernames with certain characters can't be used to access to share the data. Sharing names with only English characters. I think that is something that is a requirement in the early days that may be getting fixed later on. But creating a new file share. So once we know that we're going to try to remediate that, let's give this a second to reboot. And then we can walk through what that looks like from a configuration. So ranking to our cluster level view, going over to configure, we can then see on the left side under our vSAN tab, there's even a file services breakout for it. So not only is it enabled, is it not, but let's take a look at the file shares and say, what do we want to have from a capability? And when it comes to adding a file share, very simple. Go ahead and click our add button here. And then we can go ahead and give this a name here. So let's call this VM shares, and then this will be an NFS share. So we'll go ahead and tag that on the back end. Make sure that our protocol is correct, like I mentioned. If we do have Active Directory set up, then our SMB shares will be able to come up here. But since we have not done that yet, NFS is going to be the only protocol that we're going to be supporting currently. Once again, want to point out that the versions are NFS 3 and 4.1 that we do support. We can also manage these different file shares with our storage policies. It's what we covered before with our different hosts. We can have a default storage policy. We can go ahead and change that to our test vSAN policy as well. We'll just use our default storage policy, but it does give us a capability of having the same granular management for a singular storage system for both the file and the traditional block workloads. So another cool portion of the vSAN file services are really going to be our space quotas. And so we can share both a warning and an actual hard set quota for what these look like. So let's say for this file share at around 5 gigs, we're going to get a warning. So this is going to be sent to the admin. We're going to say, hey, you're exceeding what we're going to have, just letting you know that this is a warning of a threshold. And then we can actually set hard quotas as well. So once they kind of eclipse that 5 gig warning, once we hit 10 gigs, we're going to go ahead and hit that with a hard stop. And this is obviously configurable depending on the size of the file shares and obviously whatever we want to have from a use case basis. But once everything looks good for me creating the file share, we're going to go ahead and click next. And then the access control is going to be the next portion that we have. So we can allow no access. We can have access from any IP. So it gives us a little bit of two sides of the coin, or we can really customize that. And so if we're going to have certain IPs that we want to say, want to have read-only access, want to have no access, or even full read-write. And so we can really tailor who has access to these file shares and gives us a lot of flexibility when it comes to management. But in this case, let's just go ahead and say anyone that, any IP can go ahead and access that file share itself. Once again, the review tab, and we're going to go ahead and click finish. And so as this is building out, this is once again going to be added to our file share once we get everything created up, once that task is completed. But it's going to view the full list of file shares that we have created. And so to navigate to that, once again, from the cluster tab, we can go to configure down to file shares, and everything is going to come up. So the file share that we just created, going to give us an overview of what that looks like, the protocol that we're going to be using, whatever storage policy we have for that, and then obviously the usage data for what those file shares look like in the environment. So just kind of extending out what the capabilities could be from a file share in tandem with a traditional vSAN architecture. So one piece I did want to also touch into is going to be our encryption capabilities. And so moving to our cluster level view down to configure under our vSAN tab, once again, up to our services, I did touch on this a little bit, but we have our data at rest and our data in transit encryption. And so these are two encryption options that provide capabilities for encryption, but at different levels. So data at rest encryption obviously is going to be written at rest. So we're going to, if we're using deduplication or deduplication and compression, we're going to take those space savings, then we will encrypt, and then we will write to disk. And that is at both the caching and the capacity layer. And so both tiers are going to have that full at-rest data protection. This is going to require, from an at-rest encryption standpoint, a external key management server. We don't have that capability set up today, but I just want to make sure that we have that. If we do want to go ahead and say, hey, let's enable our data at rest encryption, we can go ahead and click edit. This will pop up our windows to make sure we have everything correctly. So space efficiency, if we're going to be using compression only or dedupe and compression, for this, let's use compression only. And then we're going to select, do we want at rest, do we want in transit, or both? When it comes to the at-rest encryption, I did mention the external key management server, that external KMS. If we already have one selected, it will drop down from the key provider. If we don't have that, we're going to need to create an existing KMS before we can apply our at-rest encryption to generate those keys. When it comes to data in transit, we actually have a vSphere key manager. And so it is going to be a native key manager tool. And so we're going to be housing those keys internal to the cluster, since that data is only going to be encrypted in transit. A little bit easier for that. And so let's say for this example, let's just go ahead and use the in-transit encryption. And then once we had everything ready, click apply. This is going to kick off an on-disk format reboot of each different disk group that we have in the environment. So it's best preferred that we set up our encryption capabilities at the creation of a cluster if possible. Another piece I want to kind of call out is that the encryption capabilities are definitely required with our vSAN enterprise level licensing. So we can kind of talk through a little bit what our standard, advanced, and enterprise levels can give us, but wanted to make sure we touched on that. So the last piece that we'll jump into before we do a little bit of a Q&A is going to be our HCI mesh, or kind of our data store sharing. So once again, at our cluster level view, over to configure in our vSAN tab, we just below our file shares, we see data store sharing. And so this was just a way to kind of alleviate the need for any sort of strained capacity or spare left capacity in a vSAN cluster. So if we had multiple vSAN clusters here, unfortunately, we only have one, and we can mount a data store for other vSAN clusters to contribute. And now with the latest edition of HCI mesh, we can actually serve up a vSAN data store cluster, so our 4 hosts here, to a non-vSAN backed cluster as well. So our traditional vSphere hosts can consume that vSAN storage as well. So if we had multiple vSAN data stores, obviously with data store sharing, everything would come up here. We could select which data store we want to mount, so our local data store here, and then we can go ahead and mount that. This is going to walk us through a little bit of a remote data store that we would want to mount. And so if we had other data stores that we wanted to kind of have a bidirectional communication with, we would select that from this tab, since we only have a singular vSAN data store. Not here, not going to give us the chance to do that today, but we would do this, click next once we selected the correct data store. And then once again, it's just going to check compatibility to ensure that we're on the proper license level to provide that function. And then we could click finish. That would mount an existing vSAN data store. So as we spun up and kind of clone those virtual machines and set those storage policies, similar to how we did at the beginning of our walkthrough, that would give us the capability of just mounting the exact same capabilities, but at a remote location physically. So that was everything I had planned to cover. Let's go ahead and pause here, and we can take some time for Q&A.
Really cool presentation. Thank you so much, Zane. I learned a lot from that. I'm sure the audience did as well. And I know we've got a lot of questions here coming in. So let's go ahead and kick that off. You ready for some Q&A?
Let's do it. Let's get into it.
Awesome. All right. Let's see. First question here that came in, they're asking, when you are running on an all-flash cluster and enable dedupe and compression, does the new update allow the loss of a capacity drive without the disk group failing?
So that's going to be more so tied around the data services that we have selected at the cluster level. So one of the newer capabilities that we do have is decoupling, deduplication, and compression. So when dedupe and compression are enabled together, if we lose a capacity drive, that's still going to count as a failure for the entire disk group as a fault domain. However, if we now have the capability of just deploying with a compression-only feature, that will treat any capacity disk failure as just a single disk failure. So the algorithm with dedupe and compression together has not changed, but we do now have an option of a compression-only data service for the cluster, which would then alleviate the result of the entire disk group going out if we do lose one capacity drive.
Very nice. All right. Next question here comes from Neil. He's asking, has dedupe and compression, have the algorithms improved with the newer versions of vSAN?
Yeah, so they have slightly improved, obviously, with each different newer version of vSAN that comes out, that's one thing that we're striving to increase is the performance capabilities of that. So while they have, I don't think I have a metric around what that is from say 7.0 to 7.0 update 3, which is our newest version there. But like I mentioned, we do take into account kind of the testing and all of the metrics that go into that, which as a result led to, like I was speaking to just before, the compression only option in comparison to kind of the dedupe and compression. So short answer, yes, they have improved. To what degree? It's kind of hard to quantify because everything is so very specific depending on which workload that we're talking about that's going to be served up for those dedupe and compression ratios.
Got it. Yeah, absolutely. Alex is asking, can you access AWS S3 buckets from VMware Cloud?
Yeah, so that's going to be strictly based on our VMware Cloud on AWS. And so since on that, everything is going to be kind of in that elastic compute kind of environment there. We do have the ability to set up those S3 buckets as kind of an endpoint for that. The basis of the VMware Cloud on AWS is obviously going to be those hyperconverged nodes is going to be the vSAN for that front end capability, but we do have those native services integration throughout the AWS portfolio for that, so we can integrate those things, those EC2 buckets, S3, etc. So yes, we do have the capability in that AWS instance to tap onto those native services for those S3 buckets for additional capacity.
Awesome. Greg is asking, can you enable dedupe and compression with erasure coding?
Yes, so great question, Greg. Yes, we can. And really the reasoning behind that is there's kind of two different sets that we're talking about there. So the dedupe and compression is really more of a data service that we're offering at the cluster level, where erasure coding is just more so how we're actually providing the resiliency in that storage policy. So we could have dedupe and compression with erasure coding or without, or even erasure coding without the deduplication or compression. And now that we have the capability with compression only. And so we do have the flexibility to mix and match there, obviously, depending on the needs of what that workload profile looks like, what we were trying to achieve from a performance and a resiliency standpoint. It may change our recommendation of what we think we should go with, but absolutely we can use those two in tandem.
Nice. Let's see. Neil is asking, do you have any best resources or vSAN best practices, resources that you can recommend?
Yeah, absolutely. So I think the number one best resource would be going to your VMware account teams. We do have specialists that kind of align to each different technology for that, so we can definitely get more of those intimate conversations. Really kind of understand what we're getting into. Is this just general information gathering? Is there a specific use case we're looking at? But also, if you're just kind of looking for general recommendations, the core engineering site, so core.vmware.com, has the majority of our HCI documentation that's going to be listed on that. So things like best practices, how to plan and design, reference architectures, and even some walkthrough videos and kind of demos around the specific features and functionalities throughout the lifespan of vSAN. So that core.vmware.com is definitely probably one of the most useful public-facing sites that we have to be able to get information around vSAN specifically.
Very nice. I'm going to check that one out myself, core.vmware.com. Another one here that came in, Alex is asking, what is the case where the vSAN default storage policy would not be compliant?
Yeah, so that's really strictly around how we structure our storage policies. So that default storage policy, if we're not compliant with that, essentially that means that we have an outage at the hardware layer or we've lost an object of that data. So whenever we define these rules of the storage policy, we tell that virtual machine and those storage objects how we're going to break and chunk those up and how they're going to be distributed on the back end. If there is an issue with how we should be able to distribute that based on the rules, then we would get that flag and warning saying that we're not compliant, meaning that the metrics that we have defined and the parameters for that policy can't be met. So we're out of compliance with what that is. Whether that be a lack of a fault domain, maybe it's a hardware failure that we have, or even a disconnection, something like that could lead to those. So there's a variety of cases that could lead to being non-compliant. But at the end of the day, it just means that there's something happening that is not allowing us to fully execute that end state that we're looking to achieve by defining those different rule sets.
Got it. Okay. And before we move on, I want to take a moment to remind everyone about the handouts tab there. That's where that you can go and try out this VMware Hands-On Lab for free for yourself with the first link, and the Hands-On Lab guide is there as well. Make sure that you click on those before we go. Those will pop up new tabs or windows in your web browser. Greg is now asking, let's see, another question here. Will vSAN support NVMe over TCP?
Yeah, so the NVMe over TCP is more so of a traditional storage capability for that. So with our traditional storage models there, really that NVMe over Fabric extends that from that local storage into more of a shared network storage. And so we do support NVMe over TCP with our traditional storage technologies with vSphere 7 Update 3. When it comes to vSAN specifically, we do use a native protocol since we're not necessarily using a general storage protocol. We are communicating directly hardware with our virtual machines in that piece there. And so it is a little bit of a different protocol there, but we do have full support with NVMe devices. And so since, for example, the Intel Optane NVMe disks that came out a few years back, we did have day one support from that. So definitely no confusion or issues when it comes to kind of the late breaking storage media that we could use as a part of that hyperconverged infrastructure. But we do take a little bit of a different look at it when it comes to kind of that protocol that we'll be communicating to those disks with.
Excellent. Paul is asking how much of this lab or the resources can be run offline?
Yeah, so the lab that we just went through is housed by VMware specifically. And so everything is going to be nested. And so we're not having dedicated bare metal servers that we're kind of running this on. It is a nested environment for that. So we do have, actually, as a part of going into the lab and provisioning that, the different checks and kind of connectivity tests that we have to see, hey, is this an issue? Do we have the connectivity that we need? So we cannot run this offline. We do have to be connected to the internet for this lab to be operable. But we do have, like we said, as we're spinning up that lab, there is kind of a pre-test and a pre-check to see what your bandwidth is, see what that connectivity looks like, and justify, hey, is this going to impact your user ability at the end state, or is this just going to be a seamless process with no issues there? So just make sure we're connected up, and then as we're deploying that lab, we'll get the answers we need.
Very nice. Next question, does vSAN use external storage arrays?
Yeah, so great question. This is obviously something we get quite a bit. So vSAN doesn't have to replace existing storage. We're just simply using that x86 server architecture to create really that virtual SAN. So those onboard disk drive bays that we have, we can turn those just from a bunch of direct attached storage and kind of disparate disks into that virtual array. And that virtual array is obviously going to be presented to the vSphere client, as we saw, through a data store method. And so if we want to use vSAN in tandem with an external storage array, that's great. We could just go ahead and create those different LUNs, create those different carve-outs and data stores that we would traditionally use, and just have that as an additional landing point for our workloads and the storage capability of vSphere in there. So it's not a one or the other. These definitely can and do often work into tandem. We've got many customers that use traditional storage for either specific workloads or just an extension of that vSAN environment as a part of their HCI vision.
Nice. Next question, what storage protocols does vSAN support?
Yeah, so that kind of goes back a little bit into kind of the NVMe over TCP question. So vSAN really only communicates with VMs through vSphere. And so there's really no need for a standard storage protocol. And so vSAN's protocol really is proprietary within that cluster that's a bit more efficient than the familiar choices that we've seen. But like we said, for things like file services or offering up vSAN as kind of an iSCSI target for a bare metal host, if we want to expose the storage outside of that vSphere cluster, then we have the capability of using that and kind of transferring the protocol. So for example, the file services, we do have NFS, I believe it's 4 and 4.1 SMB, as well as one of the protocols we do support. And so as with that, the lifestyle or the lifespan of the vSAN file services continues to be longer, we're obviously going to start introducing more supportability for those different protocols. But at the end of the day, vSAN uses a proprietary protocol inherently, but we still have the capability of offering that to other devices via iSCSI target, NFS, SMB, etc.
Nice. Let's see if we can access an AWS S3 bucket, can we access an Azure blob too? And if it is so, is it platform independent? What do you think on that one?
Yeah, so when it comes to the AWS S3 buckets and Azure, these are going to be really VMware Cloud on insert public cloud provider here. So VMware Cloud on AWS was the first partnership with VMware that happened. It was announced a couple of years ago at VMworld. Now we do have Azure VMware Services, and so it's going to be a similar concept of that vSAN backed software defined stack provided to you on Azure bare metal. But then in that instance, on the Azure VMware Services, we would be able to tap into Azure's native capabilities. And so this is really when I first mentioned that hybrid cloud methodology. We do have the capabilities of tapping into those native services that we're mentioning here, but it's not going to be all in one. We would have, say, our VMC on AWS accessing some S3 buckets. We could have a little bit of a footprint inside of Azure and AVS and access those blobs. But once again, we're still going to have communication between the on-prem instance and those different public clouds, or between those two different public cloud instances. And so that's really more of that hybrid cloud future state, really VMware Cloud vision that was a hot topic for the VMworld that wrapped up just a couple of weeks ago. So a little bit more to that question. So please, I encourage you to reach out to your VMware account team to really kind of talk through all that, and we can really get a plan together to make sure that we're understanding what those needs are and recommending the best way to achieve those and kind of tap into those native services as well.
Yeah, absolutely. Next question here, is it advisable to have an infrastructure with hybrid disks? So in other words, should you go with a hybrid or an all-flash design?
Yeah, great question. And we've been working along with that for quite a bit now too. So really, vSAN is what we call a two-tier architecture. And so the disks on the back end are gonna live at two different layers. So the first layer is going to be the caching disk or caching layer, which is really going to provide that write performance in that front end buffer. And behind that, we're going to have our capacity drives. And that's really going to be our usable capacity. That's where we're going to pull the majority of our reads from in a vSAN environment. So we do have two different topologies. So an all-flash topology, that caching layer, those caching SSDs would be SSD disk that it provides that format that's a little bit more write intensive on that side. And then the read capabilities, those capacity drives would also be SSD, but would be more so of kind of a mixed use or read intensive type of disk itself. But we still offer what we call vSAN hybrid, which would still use that SSD and that flash on the front end for that caching, but those capacity drives would then be spinning media. And so obviously with kind of the aging out of spinning media, just the general performance and the price per gig for that, we do see that more so on our small scale implementations, more at our remote edge sites, the small VM clusters that we may have for that. That's typically where we've seen that. I have been with VMware working with vSAN for going on 5 years now, and there's been a huge flip of where it was a little bit more of a trade-off and kind of a cost decision of should we go hybrid, should we go all flash. But at this point, with things like our data services and just the price of flash going down, we see most customers kind of using that future-proof protection and design and going with that full SSD all flash performance design.
Yeah, absolutely. Next question, can I run virtual machines on top of vSAN file services NFS shares? Maybe the better question might be, would you want to?
Yeah, absolutely. And that was the vSAN file services really came as an ask from our customers. Hey, we have this small niche. We have a vSAN cluster. It's working great, but we still need to consume some file services. So how can we go ahead and incorporate that? We don't want to go ahead and buy a dedicated array, an expensive infrastructure application or appliance just to be able to kind of get that in there to provide those file services. So yes, absolutely, we can run it. We have customers running it. That's why we have the service available. It really is just a means of extending a different type of storage that we can consume without having to have a little bit more of that complexity and remove that three-tier type of bolt-on architecture just to provide some sort of file service. Now, that being said, vSAN file services isn't the end-all be-all file solution. So once again, I would encourage you to talk to your local VMware account reps, your engineers, everyone that supports to say, hey, let's take a look at what we're trying to get done and see, hey, does this make sense for what that looks like? Or maybe would it be better to kind of avoid that and go to a dedicated array-based solution?
Yeah, absolutely. Here's a good question from Sergey, who's asking, what's the entry point for vSAN? What's the kind of entry level vSAN option?
Yeah, so I mean, obviously there's a difference in the level of licensing that we would have, kind of how that consumption looks. But essentially, when it comes to a vSAN design, think of it as fault domains. When we go into those storage policy basis, we're going to distribute everything between those different fault domains. And so, in our standard default storage policy, we would be using a RAID mirror, so kind of that RAID one. We would have copy one of that data, copy two of that data, and then we would need some sort of metadata component to avoid a split brain in that cluster. And so, since we look at each different compute node as its own fault domain, that would put us at three hosts, three ESXi hosts that are also contributing storage for vSAN. Now, that being said, a couple of years ago, we did introduce our two node topology. And so, really, that metadata component that sits on a physical node, we could remove the need for a physical requirement for that and really provide that metadata capability through a virtual machine. So really more of a witness appliance. And so that really would be the smallest entry point there. When it comes to costing, that's going to be really dependent upon the size of the cluster and obviously which data services we want to have there. So that would be more of a common look of how our VMware reps can get you what that pricing would look like. But from a design standpoint, we can go as low as two nodes. Those could be single socket, low core count, one disk group per, so one caching drive, one capacity disk per host. So a wide variety of how we could actually have some flexibility in deployment there.
Got it. Okay. There's a couple questions here around the differences and improvements between vSAN 6X and vSAN 7.
Yeah, so the biggest capabilities and differences between vSAN 6 and vSAN 7 would be the integration of VMware Tanzu. So the capability of building Kubernetes into vSphere, into that kernel capability to provide those same services that we need into those container architectures. So we can really kind of have those two live as equal class citizens in the same infrastructure instead of having dedicated points for our virtual machine infrastructure and a dedicated set of infrastructure for those containerized applications. And so that would be kind of a big shift, not just with vSAN, but with kind of how VMware's technology from that 6 to 7 transition has gone anyways. But when it comes to vSAN specifically, things like file services, there's been much expansions into the 7X train. Things like HCI mesh, so those cross data center sharings, and really being able to even provide that vSAN data store through HCI mesh into non-vSAN clusters, what we call compute-only clusters as well. Just some more flexibility with that. So really more so leaning into those cloud-native applications, those containerized applications, and really providing a more detailed granularity of monitoring and how we're serving up that capacity would be the greatest for there. But the core.vmware.com site that I mentioned, that core site we have, all of that information has the release notes and a bunch of those different versioning matrices to where we can take a look at what that looks like from, say, 6.7 to 7.0 update 1.
Excellent. Well, I know we're running out of time here in our webinar window. You've been so gracious to answer, 50 questions or something like that here. Before we go, if folks want to get started and try this out for themselves, I know we recommend everyone check out the link there in the handouts tab. It's completely free. And anything else we need to know about the lab, Zane?
Yeah, so the lab is something that we can spin up on demand. There is a lab manual that comes along with that. And so that's a tab that we can have up next to our lab. We can open that on a different device. That really does have a lot of good information of, for example, getting into the file services module. It gives us a bit of a background of file services, how they work, and then gives us very detailed instructions. So it's not, here's the keys, good luck driving the car. There's a very prescriptive model of making sure we know exactly what we're doing and kind of the proper ways of doing things. So a lot of great information out there. And as always, your VMware account team would very much so be happy to talk to you and have these conversations on a more personalized basis if that's something that pops up as well.
Excellent. Yeah, I'm a big fan of the VMware Hands-On Labs. Tons of labs out there available, great lab guides, all completely free in your web browser. It's a great way to learn about VMware technology. So I encourage everyone to check it out. Zane, thank you so much again for your excellent presentation and demo. Thanks for being on the event today.
Absolutely. I appreciate everyone coming out, and we hope that everyone at least learned a little bit of something. And if we don't talk to you soon, I hope you have a great end of the week and a great weekend.
Excellent. And thank you, of course, to everyone out there in the audience for joining us. Before we go, I do want to announce the winner of our Amazon $300 gift card door prize. This is going out to Alan Wish from California. Congratulations. We'll reach out to deliver that and also be contacting our Best Question Prize winner as well. Thank you, everyone, for all the great questions. And I hope that you learned a lot on the event today. Have a great day, and we'll see you next time. Bye-bye.